Alright, so let's take a look at some of the doubts that you guys sent me. So this is Neville's doubt. So we've got a volume of a regular hexagonal prism, and it's 2,800 cubic centimeters. The height of the prism is 14 centimeters. So find the side of the hexagonal base in centimeters. So basically, the volume would be area of the base times height. And we know the volume and we know the height. Therefore, if we want to find out the area of this hexagon, which is going to be the base of this prism, it should be the volume divided by the height. And well, the volume is 2,800 cubic centimeters, and our height is 14 centimeters, right? So that should give us an area of 200 squared centimeters. Alright, so let's think about this. So we've got a hexagon. It's a regular hexagon, so all the sides are the same. If you remember, we've done this before. The hexagon we can split into 6 equilateral triangles, and well, we only actually need one length, right, which is one of the sides, because all of the other lengths here, they will be the same. Each of those segments here will have the same length. Alright, so the area for a triangle, so the area of one of those would be half of 2 of those sides. So if the sides are the same, L squared, and since this is not a right triangle, sin of the angle between them, which is 60, right? Each of those triangles will have sides L the same, and all of the angles, they are also the same, 60. So this is the area of one of the triangles, and if we work that out, we would have root of 3 over 4 L squared. Now we don't know the side. This is exactly what we're looking for. This is the area for one triangle. If we're looking for the whole hexagon, we should have 6 of those. So the area, I'll try and draw a hexagon here, should be 6 times the area of one of the triangles. So that's 6 times this area here that we found before. So 6 root of 3 over 4 L squared. And we can even simplify, it should be 3 root of 3 over 2 L squared. And this area is equal to this area that we found before. So this is 200 squared centimeters. And now we can solve this. So L squared would be 200 times 2 and divided by 3 root of 3 squared centimeters. So our length, we can see that our side will be in centimeters. So now we get the root of all of that. So let's see, which is 8.77 centimeters, up to 3 significant figures. Okay, so the next doubts that I'm going to solve here, you can pause the video to read the question, but it's basically a mine, and we're given how much copper has been extracted from it. So we know that it's 4.1 million tons. So million, that's 10 to the power 6 tons, which is 10 to the power of 3 kilograms. Alright, so this would be 4.1 times 10 to the power of 9 kilograms. That's given. Now we're also given that 1 cubic meter of copper weighs about 8,930 kilograms. So there is a ratio here. We know that 8,930 kilograms is equivalent to a volume of 1 cubic meter, right? This is mass and this is volume. So if this is true, how much would be the volume of 4.1 times 10 to the power of 9 kilograms? That's the first thing we have to solve. So we can cross multiply. So here and here, so you'll find that x times 8,930 equals 4.1 times 10 to the power of 9. So x is 4.1 times 10 to the power 9. I didn't write the 1 here, it's times 1, but well, there's no point. Divided by 8,930, and that would gives us about I'll put the exact number here up to the decimal place, so you can check your answers later. But then we need to round this to 2 or 3 significant figures, so 4.59 times 10 to the power 5 cubic meters. That's the volume of the sphere. Now we need to use the equation for the volume of a sphere, which is 4/3 pi r to the power 3. So this is our radius, our volume, right? And we want to find the radius, so we have to make the radius our subject. So radius will be 3 times the volume divided by 4 pi, and I have to get the cubic root, and then I can just take this value in here. So that's cubic root of 3 times 4.59 times 10 to the power 5 over 4 pi. So that gives us approximately 47.9 meters.